Thank you so much for joining me in our meeting. I will go through 3 examples how to figure out the quantity takeoff for wood in different scenarios. One of them, for example, in this example, we have a roof besides the lateral area of the building. So we have this face, we have this face, and we have this face, and we have one more on the other side. Besides the roof area, this roof area, we need to cover all of these surface areas with plywood. Plywood sheets. So I need to figure out what is the total surface area for this building. Does that make sense? So let's start first with the walls. For the roof. If you would like to figure out the area of the roof, that means we need to figure out how much is this area and how much is this area. Then I will add both of them together. That makes sense? So be careful when you are figuring out these numbers to avoid any mistake. Read your problem carefully. The problem said the total length of the house is 75 feet. That means this total length is 75 feet. And we are given that the roof has a 1/5 rise over run. Keep in your mind, if you have any slope like this, so this horizontal distance will be called the run. And I'm sorry. Yes, this one is a run and this one is a rise. Does that make sense? So based on the given information, 1/5 rise over run, that means the run will be 5 and the rise will be 1. So if you move 5 feet, for example, you are going to go up 1 feet. If you are moving horizontally 5 inch, for example, you are going to move up 1 inch. So from this slope, I can figure out what is the sloped length of the roof. Keep in your mind, if you draw a triangle like this one, so if this one is 5, this one will be 1. This is the slope. To be better understand this one, so make this triangle smaller. 5 to 1. Now I will draw the bigger one. The horizontal distance of this triangle with the red color equal 25 feet. Based on the given information, the total width is 50. So can you tell me what is the expected height here? Based on the ratio, I will divide 25 by 5 to get this one. So how much is this height? It will be 5 feet. That makes sense? It will be 5 feet. Based on the 5 feet and the 25 feet, I can say this length of the roof will equal 5 feet square plus 25 feet square under square root. So this length will be 25.5. Based on the given information, we have overhang length of 3 feet. Can you see it? This overhang length equals 3 feet. Sometimes the 3 feet is the horizontal distance, sometimes it's the sloped distance. It's not a big deal. We can work as the length of this overhang equals 3 feet. So the total length of this side will equal 25.5 plus 3 will be 28.5 feet. So now I can figure out the area of this side of the roof. I'm talking about the roof. So the area will equal 28.5 times the total length is 75 feet. This is the area of one side of the roof. I have to multiply this area by 2 to get the total surface area of the roof. So it will be times 75 times 2. I got 4,274.3 square feet. So keep in your mind, if you are going to replace your roof, if you are going to cover it with any material, you are going to use this information. 4,274.3 square feet, the total surface of the roof. Does that make sense? Keep in your mind, let's try to figure out what is the total surface area of this face of the building. Phase 1. Phase 1, we have two phases. From phase 1, this side, and the same one on the opposite side, in this side. So what is the surface area of this side? Keep in your mind, if I delete this triangle, I'm looking right now to the area of this shape. If you cannot find out the area as a one number or in one step, you can divide this area to two parts. This part, a rectangle, then this triangle. Does that make sense? So the area of the rectangle will be 50 feet, the width, time. This height is not given. So go back to your problem. Maybe you can find something. The problem said the total height of the building is 20 feet. Total height means the height from the ground surface to the top height of the building. This is the total height, equal 20 feet. Does that make sense? So if you remember the height of this part from the triangle, it was 5 feet. So the remaining height of this part will be 15 feet. So the area of this rectangle will be 50 by 15 feet. Plus the area of the triangle, which is 1/2 time base time height. So 1/2 time base, which is 50 feet, time height, which is 5 feet. If you add them together, you can find out the area of one face, this face. If you multiply it by 2, because we have another face on the other side, you can get the total surface area of the two faces. So 50 by 15 plus half times 50 times 5, all of them times 2 equal 1,750 square feet. Does that make sense? Keep in your mind, we have another face of the building, which is this one. Can you see it? This side of the building, F2. And keep in your mind, this side will be repeated one more time on the opposite side here. So what is the area of F2? The area of F2 equal this length, which is 75 feet, time this height only, which is 15. So 75 by 15. If you have any comment, if you have any question, let me know. This is the area of one side. I will multiply by 2 because we have another side on the opposite direction. So 75 by 15 by 2 equal 2,250 square feet. That makes sense? So if all of these faces, the wall surfaces and the roof surfaces will be covered by the same type of the plywood, I can add all of them together. So the total area of all of them will equal the roof area plus phase 1 area plus phase 2 area. So the total area will equal 4,274.3 plus 1,750 plus 2,250. So the total will be 8,274.3 square feet. Assume we have plywood sheets with surface area 8 by 8 feet by quarter inch thickness. How many plywood sheets we need to order? So the number of sheets we need to order, keep in your mind, I did not consider any opening, door, windows, or anything because this information is not given in the problem. So I will not count for this opening. I don't have enough information for them. So I will divide the total surface area of the roof and the walls, 8,274.3 divided by the area of one sheet, 8 feet by 8 feet. So I need to order almost 129.2 or 0.3. So I will count or I will round this number to 130 sheets we need to order from the store to cover the total surface area of the roof and the walls of this building. Does that make sense? So it's very important to understand the given dimensions. What does it, these dimensions mean? And you need to figure out how can I figure out the total surface area of the walls, the exterior walls, and what are the total surface area of the roof. Anybody has any question? Any questions so far?
No.
Second example, we are talking about a wall in a garage. If you see the details, I'm sorry, I'm not talking about the wall as a whole part, but I'm talking about the framing system of this wall, especially the upper and the lower plates and the studs. So the diagram below shows one of the long garage walls that will be needed in your building. This wall contains a rough opening for the main door. We have opening here for the door for the garage. So this opening will be constructed in the wall. You can see all of the necessary components of the wall required to assemble it. We need to calculate the quantity to take off for the studs and the blades. Keep in your mind, regardless if you may understand this framing system or not, but just look to the sketch. Blades means we have here bottom plate and we have one here which is called top plate. Lumber at the top at this location and one more at this location, and then I will construct my studs in between. Does that make sense? Your studs, we have 13 stud. Is it 13? No, 13 is this one. This is the order of this stud is number 13. And this one is number 7. It's not a big deal. You have to count all of your studs. Does that make sense? What is the cross section of the studs? Go back. Here you go. We have pre-cut 2 by 4 studs. And you understand what is the meaning of 2 by 4. 2 inch by 4 inch. This is the cross section dimension. For the bottom plate, it's a 2 by 4. For the top plate, it's a 2 by 4. Looks like all of them 2 by 4. Looks like all of them 2 by 4. So let's start talking about the studs. Studs in the framing system of the wall are the vertical members. In this case, we have this is a stud 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So the number of studs looks like they are 18. We have a little bit here, this part and this part. You can consider them separately, but they are not a big deal. Maybe we can use the extra, the waste. After you cut your studs, we can use these pieces to construct these parts. But the total number right now, which is a big deal, is 18. What is the cross section? They are 2 by 4. What is the length of each stud? The length of each stud will not be given, but you can find it from the dimensions of the wall. If you look here, we have this little thickness is 1.5 inch. And this little thickness is 1.5 inch. So the distance after from this face to this face, it's not 7 feet 11 inch and 5/8. No, you have to subtract the 1.5 and 1.5 because the given dimension, this one from the top to the top. Let me explain it here. This is the thickness of the bottom plate. And this is the thickness of the top plate. And we are going to construct the studs in between. Does that make sense? So the dimension, which is 7 feet, 11 inch, 5/8, is given from here to here. So if you would like to figure out what is the total length of one stud, which is this one, you have to subtract this thickness and this thickness, which is 1.5 inch and 1.5 inch. You know what I mean? Sometimes you can say it's not a big deal, but to be more accurate, no, we have to consider these dimensions. So let me try first to convert this one to inch first. So 7 feet plus 11 inch plus 5/8. So this dimension equal 95.625 inch. If you subtract from this number 1.5 inch and 1.5 inch, that means minus 3 inch. So the remaining dimension will be 92.625. If you divide it by 12, so the length of the stud will be 7.71875 feet. That makes sense? So how much quantity take off of these studs, which is board foot or board measure, will equal the total number of the studs, 18, time the length of one stud is 7.71875 feet by the cross-section dimension 2 by 4 inch divided by 12. Now I can tell you how much quantity of wood we need to order for studs only. it will equal 162.1 board foot or board measure for the studs. Let's talk about the blades. We have top and bottom blades. Keep in your mind these calculations for one wall only. So imagine we have 4 walls for the garage or for the whole building. So we need to consider each separately. So for the blades, how many blades do you have? We have only 2. One at the top, one at the bottom. What is the cross section? We are going to use 2 by 4 also. What is the length of each piece? The length of each piece, you can find it from the dimension. If the dimension is not given, no, it's given. This dimension. 23 and 11 inch. That means it's 23.917 feet. This is the total length of the blade at the top and the same at the bottom. So the length equal how much? 23.917 feet. So how much board foot or board measure equal the number to the length of one piece, 23.917. What is the cross section? 2 by 4. Each will be written in inch divided by 12. So the total will be 2 times 23.917 times 2 times 4 divided by 12. I got 31.9 board foot. So to construct this wall, we need to order studs with this amount, 162.1 board foot. To construct this plate, we need to order 31.9. If we are using the same material, the same type, the same dimensions, 2 by 4, I can add the 2 numbers together. So I will order around 200 board foot for the whole members. That makes sense? It's not required in this example, but if, as you know, we are going after you construct this framing system, we are going to add board from this side and one board from the other side, sheathing to the wall. So what is the area of the plywood or the sheets we need to order? Keep in your mind, this total surface area, we have to subtract this door or this opening. Does that make sense? So the area equal 23.917 times the total height, which is 90, which is, this number is 7.97 feet. So 7.97 feet. This is the total surface area of the wall. I will subtract the area of this door. Maybe the dimensions are not given or not accurate enough. So this is one is 16, 16. Until this one, we can assume it 14, 12 maybe. So the total width of the door, it's not given, but we can imagine how much it will be around 40. Yeah, we can assume it 40 inch. And for the height, it's not given, but you can find it from your AutoCAD drawing or whatever. So the total height, maybe we can assume it like 7 feet. So 40 feet equal 3.3 feet. 40 inch, I'm sorry. 3.3. So I will subtract the area of the door, 7 feet by 3.3 feet. Keep in your mind, this is one face of the wall. We have another face on the other side, so I have to multiply it by 2. I will explain it just a moment. So 23.917 times 7.97 minus 7 feet times 3.3 times 2. So the total surface area is 335 square feet. So we need to order plywood with a total surface area 335 square feet. So guys, keep in your mind, when you are going to construct your wall, here is the stud. Here is the second stud. Here is the third stud. And so on. When we are covering these studs with plywood, we are going to put a sheet from this side and another sheet from the other side. Does that make sense? So we are sheathing the wall from this side and from the other side. This is the reason why I multiplied by 2. And keep in your mind, if you are going to subtract the door from this side, the door will be subtracted also from the other side. That makes sense because you are going to the door and getting from the other side. So this side of the board and this side of the board must be subtracted by the door area. Does that make sense? So just to give you a hint, the area of sheathing for the wall is multiplied by 2 because we have 2 sides, this side and the other side. Does that make sense? This is another type of question you may find. The last question I would like to cover today, we have framing system for the floor. The framing system for the floor, I will focus only on the joists. If you look to the given information, we have here cross beams, this one, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have the number of joists equal 11. And these joists are 2 by 8. So the cross section is 2 inch by 8 inch. Does that make sense? And what is the length of each piece? The length of each piece can be found from the layout. The total length here is 16 feet. So maybe we can consider the total length of your joist. It's not exactly 16 feet, but we can assume it's 16 feet. Do you know why? Because we have here a beam at this side and another one on the other side, and the joist is in between. So the distance 17 is given by this. So if you would like to figure out the actual length of the joist, which is from this face to this face, we need to subtract this thickness and this thickness. I think this one and this one will be 1.5 inch, so we can subtract the 3 inch, but it's not a big deal. So we can assume it, I'm sorry, this is 16, 16 feet. So how much board foot for the joists only? I'm talking about the joists. So the number is 11. The length of one piece is 16 feet. The cross section is given 2 by 8. divided by 12. 12 is a constant number. So 11 by 16 by 2 by 8 divided by 12, I got 234.67 board foot.